guys and welcome back to my channel. This is episode number 4 of the Glaciated Landscape and Change series over on my channel. We are going to focus today on periglacial landscapes and change for you, and I hope this is really useful. The response I've had so far on this series is really encouraging, and I know there are a lot of you there that are really finding this useful, and if that is you, please do share that with a friend. Please share it with your teacher. I know that might seem a bit strange, but I want this to reach as many people as possible so that I can help as many of you as possible with your A-levels, or even if you're not studying geography and just want to know a little bit more about the world, what's going on, how the world has got to where it is today. Stay tuned, that's what we're on about. If this is your first time here, hello, I'm Lara. I am a second year geography and education student, and I have a passion for geography that I want to share with you all. So I make geography content over on my channel, revision series. So I'm going to be focusing on all the topics throughout the Edexcel specification, starting with the ones I studied, and then I'll go on to the ones that I haven't studied, which might be a little bit more difficult, so it'll take me a little bit of time to get my head around it. But without further ado, let's get straight on into this video. So what are periglacial landscapes? A periglacial landscape is found on the edges of a polar environment, on the fringes of a polar environment. Whilst they do not have a permanent ice covering, periglacial landscapes experience extreme cold throughout most of the year. They have penetrating frost and periodic snow cover throughout the year, so it's kind of a borderline environment where it's often very cold, but sometimes it thaws out. Areas affected by permafrost affect about 25% of the world's landmass today, but in the past this was a lot more extensive. What actually is permafrost? Permafrost is where a layer of soil, sediment or rock below the ground remains almost permanently frozen, the active layer of the ground, so the bit just under where your feet lay, that is permanently frozen. I'll insert a picture here of what permafrost looks like. It reaches depths of 400 to 500 metres, but in some areas it can reach about 1500 metres deep. Permafrost may be continuous, discontinuous or sporadic, and that just depends on the temperature range that it sits within. So sporadic permafrost sits between the temperature of 0 degrees and minus 1.5 degrees. Discontinuous permafrost sits between minus 1.5 degrees and minus 5 degrees. And then continuous permafrost, so it's constant, goes from minus 5 degrees to minus 50 degrees centigrade. So there is quite a big difference, and that's how you specify which kind of permafrost it is. Cycles of intense freezing and thawing mean that surface sediments thaw in summer. They melt, resulting in a saturated layer and a possibly mobile active layer is what it's called. It's the small area that sits above the permafrost. This picture shows a deep permafrost in northern Alaska. Notice that there's a thin layer of brown unfrozen soil at the top of the permafrost. This is the active layer that I was talking about. Drainage is prevented by the permafrost. No water can get through the ice. So the active layer will often become oversaturated and quite boggy. There'll be an oversaturation of water in it. What are periglacial landscapes like? Periglacial landscapes, such as those found in Alaska and parts of northern Europe, Russia and Canada, are typically wide expanses of largely featureless plains covered with low-lying marshy vegetation. Lakes or streams are also common during the summer months when the snow has melted and the permafrost has thawed, but there's still that little active layer on top of it. The environment is characterised by tundra vegetation, which consists of low-growing plants such as mosses, lichens, grasses, dwarfs and shrub trees. Their small waxy leaves are well adapted to reduce water loss caused by exposure to high, strong winds. They flower and seed in just a few weeks. Tundra plants also are able to cope with thin soils and waterlogging on flat, poorly drained land. Thaw lakes are also common. They form during the summer when any lying snow melts. Water retains heat, and its relatively dark surface also absorbs radiation from the sun. This warmth increases the depth of the thawing of the underlying permafrost, forming unfrozen zones called talics. What geomorphological processes are at play? Geomorphological processes are those that result in the modification of landforms of the Earth's surface. They shape the Earth. Although cold environments may appear inactive, the geomorphological processes that act upon them can be surprisingly vigorous and effective. Geomorphological processes are most active at the margins of cold environments, so in our periglacial landscapes, where precipitation is high, liquid water is readily available, and temperatures hover around and below freezing. This picture shows a proglacial lake at the snout of the Grímsvötn glacier in Iceland. Please excuse my pronunciation. Notice the vast deposit of glacial debris in the foreground, which forms hills and ridges. Rivers flowing from the lakes actively erode this landscape during the summer. The exposed mountains in the distance, when their covering of snow, will gradually be broken down through the process of weathering and mass movement. This periglacial landscape is clearly being actively shaped by geomorphological processes. Periglacial processes and landforms. Geomorphological processes in periglacial landscapes are mostly associated with frost, ice and snow, together with meltwater. So frost causes frost shattering, freeze thaw and weathering, which can form blockfield and talus or scree. Snow, through the process of nivation, forms nivation hollows. Ground ice, through the process of ice crystals and lenses, known as frost heave, can create patterned ground or sorted stone polygons. Ground ice through water contraction can also cause ice wedges. Ground ice also can freeze the groundwater, creating pingos. Meltwater, through the process of solifluction, can form solifluction lobes. Meltwater through meltwater erosion can form braiding, river braiding. And wind through wind-blown sediment can form loess. I don't know how you pronounce this word, it's here. Frost action is one of the most important processes in a periglacial environment. Frost shattering, also known as freeze-thaw weathering, commonly affects bare rocky outcrops on a high mountainside. The process begins where rain or meltwater seeps into the cracks below the rock. When the temperature falls to 0 degrees or below, the water turns to ice and expands by about 9%. This exerts stress on the rock, enlarging its cracks and pores, as the process of freezing and thawing is repeated until cracks become larger and chunks of rock break away and pile up as scree at the bottom of a slope. Frost shattering can create extensive areas of broken up, angular fragments of rock. These are called block fields. Nivation is an umbrella term used to cover a range of processes associated with patches of snow. These processes are most active around the edges of snow patches. Fluctuating temperatures and the presence of meltwater promote frost shattering. Summer meltwater will carry away any weathered rock debris to reveal an ever-enlarging nivation hollow. And slumping may also take place during the summer, as saturated debris collects due to the force of gravity. As long as the freshly weathered material is removed by meltwater or a mass movement process, the nivation hollow will continue to be enlarged. If climatic cooling takes place, the hollow will eventually become occupied by glacial ice, and it then may be enlarged to form a corrie. Ground ice. In extreme low temperatures, the ground contracts and cracks develop. During the summer, meltwater fills these cracks and then freezes in the winter to form ice wedges. These increase in size through repeated cycles of freezing and thawing, like we saw all the way back in the block fields. These also affect the ground surface by forming narrow ridges due to frost heave. In the summer, ponds of meltwater then form in the hollows between these ridges. As ice wedges become more extensive, a polygonal pattern may be formed on the ground, with the ice wedges marking the sides of the polygons. This is known as patterned ground. Stone polygons are a feature of patterned ground and are directly associated to ice wedges. Frost heave causes the ground to expand and lift soil particles upwards. Smaller particles may then be removed by wind or meltwater, leaving a concentration of larger stones lying on the top of the ice wedges, marking out the polygonal pattern. However, sloping ground can distort the polygons as the stones gradually slide or roll down slope, leading to the formation of stone stripes rather than polygons. The freezing of water in the upper layer of the soil, where the permafrost is thin or discontinuous, leads to the expansion of ice within the soil. This causes the overlying sediments to heave upwards into a dome-shaped feature which is less than 50 metres high, known as a pingo. These dome-shaped hills may be 500 metres across and are mainly found on sandier soils. There are two types of pingos. There are open pingos. This type of pingo is called an open pingo, or an East Greenland type. A closed system, or Mackenzie type pingos, are typically low-lying areas with continuous permafrost. On the site of small lakes, groundwater can be trapped by freezing from above and by the permafrost below as it moves inwards towards the lake. Subsequent freezing and expansion of the trapped water pushes the overlying sediment upwards to form a pingo. If the centre of the pingo collapses, it may infill with water to form a small lake. Over 1,000 of these pingos have been recorded in the Mackenzie Delta in Canada. Meltwater. Solifluction is the slow downhill flow of saturated soil. It is a common process in periglacial environments, where the active layer provides enough water to allow flow to occur. As the saturated soil slumps downhill during the summer, it forms solifluction lobes. Meltwater can also form braided rivers as it flows across glacial outwash plains. Wind. A lack of vegetation and a plentiful supply of fine, loose material in glacial and periglacial environments enable strong, cold winds to pick up large amounts of material and redeposit it elsewhere. It covers large areas of the Mississippi-Missouri River in the USA, as well as in northwest China, where in places the material is over 300 metres deep. The Canada case study. Periglacial landscapes. The largest bay in the Arctic archipelago, I don't know how to say it, is Canada's Baffin Island. Baffin Bay and Davis Strait on the eastern side of the island are often open during the summer, but the western side is usually closed by ice all year round. It is typical of a periglacial landscape and has continuous permafrost. Baffin Island has a number of ice caps, the largest being the Penny and Barnes ice caps. Its topography ranges from rugged mountains to flat lowlands. The coastal strip between the two northern peninsulas and the Fox Peninsula is littered with lakes and ponds fed by runoff streams. Like all periglacial areas, Baffin Island has a tundra ecosystem. Globally, there are three types of tundra: Arctic, Antarctic and Alpine, and all have similar conditions. In Canada, the southern boundary of the tundra extends from the Mackenzie Delta to the southern Hudson Bay, and then northeastern to Labrador. Winters in Baffin are long, dark and cold. However, during the short summer, the snow and soil layers above the permafrost, the active layer, melt. This creates and feeds a vast network of streams, rivers and wetlands. The waterlogged soil and 24 hours of sunshine during the summer period boosts rapid plant growth, with densely packed, low-lying plants growing in the tundra's lower latitudes. And that is the end of episode number 4 of this series. I hope you enjoyed, I hope you learned something. I apologise that this was a longer video, but this had a lot to go with it, and I hope you learned something. If you did, please subscribe down below. I make these every single week, and share it with a friend if you know someone who might find this useful. I do apologise about the wind and the planes and the birds and all sorts. It's very hot in here, so I've had to have the door open, but it's just making a lot of noise. But yeah, I will see you next week for episode number 5. We are looking at mass balance and glacial systems, so I will see you then. Bye guys.